All right. So next Monday there's no class. Remember, don't show up Monday. Your test will be the week after, so we'll have one more lesson we're going to do on Wednesday next week. Then we'll review for the test the Monday after, and then the test will be that Wednesday. The final schedule has been released. Our final is on Wednesday, May 8th. So it's not the 13th, which is awesome. Yeah, so it is Wednesday, May 8th from 9:30 to 12. So start time's the same. It'll just go a little bit longer. I'll be here at 9, so you can come in early. Whenever you finish the final, you're done. You can go. So it'll be on Wednesday, May 8th, which is awesome. It shouldn't.
Question.
My finals are not typically much longer than my regular tests, so it shouldn't be too bad. That was going to be your question. Yeah, it might be a couple questions. It might be like 12 or 13 questions, but it's not going to be much longer than that. So I'll be here at 9. It's from 9:30 to 12 officially. So, but like I said, I'll be here at 9 like I normally for the test days. Yeah, it works out great for me. My final, the other class is on that Tuesday, so I'm done on Wednesday. So I'm done early, which is awesome. Yeah, time is flying. Other than that, I don't think anything else crazy that I need to explain or talk about. Yes, all homework is due. If you're in the possibility of being exempt for the final, you need to have all your homework done before the Wednesday before. If you're not, then your homework is due the day of the final. 100% completed, yes. So, if not, I'm not going to check the grades on the homework until after the final's done anyway, to finally put all the stuff in Blackboard and whatnot. So, all right. So today we're going to look at everybody's favorite topic in the world: word problems. Just blame it on all the people that always ask, when am I ever going to use this? This is why we make word problems. So actually, a bunch of these problems that we're going to see are actually very similar to problems that you've already done. So these are known as optimization problems. So in your college algebra class or your pre-calc classes and stuff, if your teacher gave you a problem, it's like, okay, you're building a fence on a river and you need to figure out the maximum area inside the fence given a certain perimeter, like those type of problems. Like you could do those with just a parabola and you're just finding your vertex. That's optimization. We're going to look at things a little more complicated. But in general, it's those types of problems. But now that we have our calculus and we know that we can use the derivatives to figure out where those peak points are, the maximums and minimums, it makes our lives a little bit easier so we don't have to do all the complicated stuff with the polynomials that we're given. So we can use our calculus to actually help us figure out these problems a little easier. However, the vast majority of these problems are not, the actual math isn't difficult. Typically, your struggles when you have a word problem is, how the heck do you set it up? Like, what are the variables? What am I looking for? What's the equation? Once you get to the equation, it's typically pretty easy. It's the setup that's a pain. So hopefully, I'll be able to help you with that a little bit today. A couple things that you want to do when you're looking at any type of word problem is the first thing is you want to actually read the problem. Figure out what they give you and what you're looking for. The next thing is, and a lot of these problems that we're going to look at today, drawing a picture is very helpful. All right, drawing a diagram can be helpful to figure things out. It gives you a visual representation of what's going on. Next thing is introducing letters. You do not have to use X's and Y's. Okay? I know everybody likes, oh, it's X. Like, use something that makes sense for the problem. If we're talking about perimeter, use P. If we're talking about chairs, use C. If we're talking about movies, use M. It's like use a letter that makes sense for the problem, because then when you get your answer, you will not have to realize, okay, what was X again? Like, M was movies. Okay, that means I have 5 movies. That's the thing. So use something that kind of makes sense for the problem. And then do your math to figure out the problem is basically the rest of it. So, all right. Okay. Let's look at one. We'll start off with the easy ones. A farmer has a bunch of fence. So he has 2,400 feet of fence, wants to fence off a rectangular field that borders a straight river. He needs no fence along the river. What are the dimensions of the field that has the largest area? All right, so what did they give me? Yeah, so the fence is 2,400 feet. That's really all they've given me, right? So let's draw a little picture. So there's my fence. There's my river. So if we label this X, what's these two sides got to be? Okay. So that's Y and Y, right? Okay. So I have 2Y plus X is 2,400 feet, right? So X equals 2,400 minus 2Y, correct? Okay. We want the area. So we want the space inside here, right? Because we want to maximize my area. How do I find area of a rectangle? Okay, so area in this case, the length of this fence is what? And the width is Y. Okay. Do we really want to do this problem with 2 different variables? No. Can we change one of the variables into something else that would now have the same variables? Yeah. We can change X into Y, right? So I can say my area is now 2,400 minus 2Y times Y. Right?
Huh? Y is just X.
No, the Y is Y. And I had X was that, right? So we had 2Y plus X equals 2,400, right? That's the 2,400. And I solved that for X. So X equals 2,400 minus 2Y. Normally, you're right. Normally, you'd have these all in terms of X. And I think that's one of the things that I think people get really stuck on. It's like, oh, I have to have it this way. Stop that mindset of thinking. Okay? You can do this in any way you want. All right. So could I solve this for X? Yes. Could I have this Y equals over here and have it solved? Absolutely. It's a little more work. And it doesn't matter. It's not going to change my process. Okay. So it's not going to change my answer at the end. So we now have my area. So we want to maximize my, I'm sorry. We want to maximize my area. So we're looking for my peak. So instead of, so let's look at this equation. That's really what we need. So I'm going to distribute this. What's my derivative? Okay. So when does this equal 0? So I have negative or 2400 minus 4y equals 0. So negative 4y equals negative 2400. So y equals 600. Is that a maximum or a minimum? What's my second derivative? So it's always going to be concave down, right? Which means this is a maximum. That's what I was looking for. So if y is 600, we had x equals 2400 minus 2y. So that means x would be 1200. So those are my dimensions. Did we answer the question? What are the dimensions of the field that has the largest area?
Oh,
We did.
well, we didn't quite find. X was the area.
No, x wasn't the area.
Oh. We didn't find the area, we didn't plug it back in.
Right, but did the question ask for the area?
Oh, dimension of the field.
Right, it didn't ask for the area, it asked for the dimensions. Do we have the dimensions? Yes, we're done. Yes.
I'm a little bit confused. I thought the area would be the same no matter what the dimensions would be, but you just multiply it. Like you can make it like super narrow and super long.
Okay, so if I have 1 foot as my y, my x would be 2,398 feet, right?
Yeah.
What's the area?
2000.
2,398 times 1, which is 2,398 feet squared, right? Okay. If my y was 2, my x would be 2,900 or 2,396, right? Times 2, is that going to be bigger than the original area? Right. So area is not always the same.
Okay.
Area changes. My perimeter doesn't change. My area changes. Okay. So that's right. So like the reason why this wasn't on all 4 sides is by definition, the biggest area that you can get if you have all 4 sides is a square. So typically when you see these type of problems, they have one side that's open, it's on a barn or a river or something like that, because then it forces you to actually do the project, like the actual parabola to do it. It's not just a square. So if you're going to build your a pen for your dog in your backyard, keep that in mind, that area changes and you want to give your dog the most area to run around. Okay. Yeah. So we solved my first derivative for 0, because that's going to give me my horizontal asymptote. That's how I got to 600. That makes sense? Okay. I took the second derivative. The second derivative is negative always. So that means it's going to be concave down. So that means that point has to be a maximum. The other way you could have done it is you could have plugged it back into the problem and found out that that was going to give you the biggest area. But remember, we have that second derivative that tells me if it's a min or a max, so I don't have to necessarily do that part. That saves me some work. Okay. All right. So you can start to see how using your first derivatives and second derivatives can start helping you to figure this stuff out. All right.
Oh, we're trying to find the smallest.
You're trying to find the least amount of metal. Why would this be important? Why do you think they'd care? Yeah. They're going to buy, the more metal you buy, the more it's going to cost you to make that can, right? So you're going to want to minimize that as much as possible so you're not wasting money. So let's look at it as, here's a nice little diagram of a can. So what are we looking at? What's the formula we're really looking at for this problem?
We're looking for the smallest. No. Surface area?
We're looking for surface area. The metal in this can is surface area. Okay, so we are looking for surface area in this case. We are given a volume, that is correct. But we're in essence looking for the formula surface area. So what's the formula for surface area of a cylinder? So if you took a can and unrolled it, right, it's length times width, right? Or length times height. So it's height, and the top is going to be the circumference of the circle, which is 2 pi r. So 2 pi r times height. That's the round the outside of the can. And then we have the top and the bottom of the can, right? The top and the bottom of the can is the area of a circle, which is pi r squared. And we have 2 of those. So it's 2 pi r squared. So there's your surface area formula. Huh? You probably did at some point in geometry class in high school. You just don't remember it. But notice that I didn't say memorize the formula. It's like, look at what you know about a can and you can determine that formula. Like, you know how to find the area of a circle. That's the top and the bottom. That's pi r squared. So I got 2 of those. That's good. And then if you think about, like, and that's one of the things that when I'm starting to do actually like drawings and stuff like that to actually create things in 3 dimensions, a lot of times you actually take something and you unfold it to do stuff to the outside and then you refold it. That's the can. Like, you're unfolding that piece of metal that's going around the outside. You now have a rectangle. That's just length times height. The height is still the height of the can. That's fine. The length is what matters. The length was the circumference of that circle, which is 2 pi r. So you can come up with the formula just knowing what you know about circle and visualizing the actual can. It's not. It's because it's that's the area of a circle.
Yeah.
And I have 2 of them.
Thought it was just a radius.
I have the top and the bottom of the can. So the area of a circle is pi r squared. That's the area of a circle. That's the formula for that. I have 2 of them. That's why it was 2 pi r squared. So that's the 2 isn't because that's squared. It's just I have 2 tops and bottoms. All right. So the question is now we've got that. What did they give me though? They gave me the volume of the can, right? So does anybody remember the volume of a cylinder? Right. So volume is pi r squared times h. In this case, we're going to make that 1,000 milliliters. Yeah. All right. So remember, the hardest part of a word problem is not the actual like calculations normally. It's coming up with the information that we have to figure this stuff out. So we've got our surface area formula. We've got our volume formula. My surface area formula is what we're really going to work with because that's the thing I want to minimize. I have two variables in my surface area formula now, right? I have an R and an H. I need to get rid of one of them. Okay? I have multiple R's and I only have one H, correct? So let's get rid of the H. Make my life a little bit easier. So let's solve my volume for H. So H is going to equal 1,000 divided by pi r squared. The only reason I changed 1 liter into 1,000 milliliters is so we weren't dealing with one. Okay, one kind of makes things a little more like it doesn't necessarily make things more complicated. It just weird things happen at zeros and ones, so you don't really want to use them if you don't have to. So by changing to 1,000, we eliminate the possibility of something strange happening at the number 1. So, and it's not going to change my problem because we're looking at minimizing cost, so it's not going to really change much there. All right, so my surface area formula is 2 pi r times 1,000 over pi r squared plus 2 pi r squared. That's my formula.
Did you turn milliliters? Sorry, did you turn milliliters into cubic centimeters to kind of help with distance later? So you also do that.
I think it's actually, isn't a cubic centimeter the exact same as a milliliter anyway?
Yeah, I just suppose.
Yeah, I don't think it's really gonna matter. In all honesty, I'm literally just gonna keep it as 1,000. We're gonna worry about it that way. Like we're not even gonna think about the milliliters at that point. Yeah, I was gonna say like I'm not I'm not perfect on all my conversions metric, but I'm almost positive those two are the same. Almost sure those are the same. How'd I go for what?
I'm just trying to wonder where it goes from.
This?
Yeah.
That's what we're gonna work on. All right, so I've got this. What's the first thing you're gonna want to do? Yeah, let's try to simplify this as much as possible. All right, right now I got fractions and parentheses. Let's try to simplify this a little bit. Okay, so I got 2,000 over R, right? Because the pi's cancel out. I have pi on the top and the bottom. One of my R's cancels out. And 2 times 1,000 is 2,000. Plus 2 pi R squared. So that's got to stay. All right. If we're minimizing or maximizing or finding my extremes, now what do? Find my derivative. So what's the derivative of 2000 over r?
1.
Yeah, remember that sometimes it doesn't. Remember that 2000 over r is the same thing as 2000 r to the negative 1. Derivative of that would be negative 2000 r to the negative 2, right? So I got negative 2000 over r squared. And this becomes 4 pi r. Yeah, I could have wrote as 2000 r negative 1. Instead of writing as 2000 over r.
So we just ignore the pi.
Yeah, because pi is a constant. Pi is no different than like 3. And I did 3 times. That's how I got 4 times pi. Because I had 2 times 2 times pi, which is 4 pi. It's no plus. I don't have to do distributing or anything else like that when I'm multiplying. All right, so I need to set this equal to what?
0.
I need to set this equal to 0. So as it sits right now, is this going to be easy for me to figure out? Huh? You feel like you got it? Then go ahead. We. Ye. So the collaborative we. Not me. We. What do you want to try? So if I take the second derivative, that's going to give me, it's not going to give me my critical value. It's going to tell me if it's a minimum or maximum. Well, we need to minimize. So we do need to figure out if it is going to be a minimum or maximum. So I will have to do that eventually. But as it sits right now, solving that for 0 is going to be difficult because I have multiple r's and I don't really have a fraction or anything else that's going to make life easy. So let's do some algebra. Let's take this and make one fraction. Let's put this together so it's one thing. Then I have something over something that I can then say, okay, I set the top equal to 0 and I'm done. That type of thing. So remember when if you're multiplying things on both sides, you have a tendency to eliminate things and eliminate possibilities. So you don't technically want to try to do that a lot of times. Could it work for this case? Maybe. I don't think it's going to make your life easier, though. It might make it actually a little harder. So, but watch the way I'm going to show you how to do it. Let's just make this one, because if I have it as one fraction, I know my denominator can't be 0. Like, that can't happen. So the only way for a fraction to be 0 is at the top 0, right? So then I don't even have to worry about the bottom. I'm literally just looking at the top. So it saves me that one extra thing that I have to look at, which might be nice. I don't know. It might, either way might work for this one. So I just need to put this over r squared, which would mean that would have to be r to the third, correct? If I'm putting the r squared down the bottom here, I have to put the on the top too, right? So I have negative 2000 plus 4 pi r to the third over r to the third, or r squared. So I really just need to do negative 2000 equals 4 pi plus 4 pi r to the third equals 0. So yeah, in this case, it doesn't work. It doesn't actually matter. It comes out to be the exact same thing. So 4 pi r to the third equals 2000. Pi r to the third equals 500. R to the third equals 500 over pi. So r equals the third root of 500 over pi. Any questions on how I did the math over here? Yes.
Do the r squared, why doesn't it affect with the 4 pi? Like, why does it only affect the r squared?
Because it's all multiplication. So it's 4 pi r times r squared. Because I multiplied the top and the bottom by r squared. It's a cube root. Good question, though. If it was a square root, I would have. So in this case, it's r times r squared, which is r to the third. I think the thing you guys are thinking about is you only have to distribute when it's addition and subtraction. If it's multiplication, it's just multiplication. You're not distributing. So that 4 pi isn't, like, I don't have to multiply the r squared times 4 pi because it's not 4 pi. It's 4 pi r. So it's 4 pi r times r squared. The r's go together, become r to the third. So. Well, that's now my radius. So that's now telling me how big my radius has got to be. Now I'll have to figure out my height in a second. But yeah. Yeah, you can plug that into a calculator, get a number up. One of the things you actually brought up, you said, is it plus or minus? It's not, because it's cubed in this case. However, if it was squared, would we have had to worry about the plus or minus in this case? Right. I can't. It's not a negative square root. I can't have a negative radius. Okay. So this is one of those ones, like when I'm normally talking about domain restrictions and stuff, I typically talk about dividing by 0. You can't have a negative square root. Those are things that you can't have. However, there's a third one that most people don't talk about. It's the real life restriction. In this case, my domain, the lowest r could be is 0. So while, yes, I could have a positive and negative square root, and mathematically that is correct, in this problem, the negative one wouldn't make any sense because I can't have a negative radius. You can't have negative length. You can't have negative height, those type of things. So when you're looking at this problem, when you're thinking about your domain and the restrictions, that has to come into play. Okay? All right, so we've got our radius. It's messy, but that's okay. So I've got my radius is the cubed root of 500 over pi. I can plug that into a calculator and get a specific answer for that. We are not going to at this yet, which is fine. So I now know my radius is the cubed root of 500 over pi. So for my height, I can now plug that into here. So my radius is this. And my height was 1,000 over pi r squared. So my height is 1,000 over pi, 500 pi to the 2/3. So that's my radius, and that's my height. Now, this is a realistic problem, correct? So there is no point in me leaving my answer like that, because again, this is a realistic problem. So we would take those and we plug them into a calculator and get the exact answer. The reason why I didn't do that before I plugged it into my height was because if you put a decimal in there, it gets kind of messy, and you want to get as exact as you possibly can when you plug it into the calculator to get your answers. So we have the cube root of 500 over pi. And then we have 1,000 divided by pi, 500 over pi to the 2/3. And doing both those in Desmos, my radius is that, and my height is that. No.
So, is there a reason why we need the height? Because we already have the equation for the surface area with just the radius.
Right. So you technically don't need it. But if you're going to send this off to a manufacturer to produce it, you're going to need the height.
Question, like, can you look at it, see like there's multiple different ways you can make this can using dimension, or well, is there other ways to do it? Or is this like the one and only way with these diameters?
So there's a bunch of different ways you can make this can. This is the minimum amount of material you would need to make a 1 liter can. Okay. So if
You make it long and then up?
no, like you would actually, this is the exact dimensions. Your height is 10.8 centimeters actually, because we're going cubic centimeters. So 10.8 centimeters and 5.4 is my radius. That would be the exact thing. And we're talking about aluminum right now is $880 a kilogram. If you're making 1 million cans for oil, that adds up pretty quick. So you would want your thing to be as specific as possible. And this is how they do these types of things. This is how they figure out the height of a can, the most optimal way to do things. Okay. So, same thing with the, if you're looking at your movie theaters, when they're making like popcorn buckets and stuff. What is their goal? When they're making their popcorn buckets, do they want to maximize volume or minimize volume?
Well, they want to maximize their value.
They want to maximize their value. So they want to minimize the volume to a point, but make it look bigger. Which is why your cans are slanted in. That minimizes the value, looks taller, looks bigger. It minimizes the volume, which means they're not going to put as much in, and they're making more money. So the worst ones are the ones that literally are a cone. Like those are the worst ones, but that's what they do. That's because their goal is to make money. Their goal is to minimize their costs. That helps minimize their costs because they're putting less popcorn in that bucket. And they're doing, somebody, not the guy behind the counter is doing this, but somebody has done this to figure that out. So the thing, somebody's done it.
Into a movie theater.
It's like, let's see, how are you screwing me today?
Calculates how well they staff.
All right, read the problem, draw me a picture. A picture doesn't have to be nice. A sketch is fine.
It's downstream.
Yes. Oh, negligible?
Yeah, what is that?
That the water really isn't pushing. Like there really isn't a strong current.
So she's not going up or down.
Right. So you, in essence, that doesn't make much difference in this case.
Actual picture?
I want a sketch. Because a sketch is going to help you start looking at the information. Huh? No, of the information.
What was it about?
I want you to draw a river with the data, with the information on it. This is Jeff Bezos' new mega yacht. And she's rowing it. Right.
Oh, I see.
Yes, sir. This is right so far. This represents the river, and this is the bay.
So the middle is the river.
Yeah, so this is the first bay, and this is the width of it, and then this is the width.
The width is 3. The river is 3 kilometers wide.
Oh, so this should be 3 then?
Yes. You have your 3 and your 8 and backwards.
And the 8's? What's the 8, Professor? Oh, that's the distance traveled.
Yes.
Okay.
So the length is 8 kilometers?
Yes.
This is, okay, so would this be correct? So this is 3. This is 3.
Well, it'd be straight across, but yeah.
And this and like from down here to here is 8.
I'm going to give you a picture.
I think I drew it sideways.
Start today,
Okay.
and go to B diagonally by going across the river. She goes straight across the river, it's 3 kilometers. But C is 8 kilometers. So that's what you're really trying to just cut back over here, figure out.
Oh, wow.
the drag distance.
Thanks, Lindsay.
All right, there's our picture. So let's see where they got this information. So they said the river was it 3 kilometers wide? So the river is 3 kilometers long. Yes, they drew a nicer picture than any of us could draw.
That's like an animation.
Well, yeah. We know that we want to reach a point 8 kilometers downstream. So we're starting here. 8 kilometers downstream is where we need to end. Okay. So she's obviously got to row across the river. So she's got to cross the river and then she's got to go down. So the question is where should she go? Should she row all the way down to the point? Should she row partway around the point? Where should she row so that she can maximize or get there as fast as possible? And they tell her that she runs or rows at 6 kilometers per hour and runs at 8 kilometers per hour. So if she rowed directly across, that would have taken her how long? 1 hour. Well, directly right here, that would have taken her a half hour, right?
Yeah, roughly.
And then 1 hour to get down here. So that would have taken her an hour and a half. Correct? So if she was this way and then down, she would have taken an hour and a half.
She went A to B, 8, 6, 3. Oh, it's a little.
Well, that's the thing. It's like it's a matter of like if she went directly down, like that's also something we can easily figure out, right? That's a Pythagorean theorem.
Yeah.
So 3 and 8, 3 squared plus 8 squared, so 973. So the square root is because we're looking for the diagonal side. No, that's 8. That's 3. That link's right there.
Oh,
A little bit under an hour.
That's Pythagorean theorem. So that's the square root of 73, which is about 8.5. All right. So if we divided 8 by the 6, it's a little less than the hour and a half, right? Okay. So it's faster for her to row directly there than to row right across the river and then run down. Okay. So, but is there a point somewhere in the middle that would be even faster? That's the question. And that's what we've got to figure out. All right. So we've got our picture. We kind of have a general idea of what we're planning on doing. Now we've got to figure out our formulas and calculations to do this, right? Okay. So how do we what? How do we find u if we don't know x? Pythagorean, we're gonna set up an equation for it. All right, so this is the key piece of information, is that point there. So AD, what's that length? So it's the square root of 3 squared plus x squared, right? That's the Pythagorean theorem to find that red line, correct? Okay. And whatever that is, we would divide by 6 to get the speed, correct? Or to get how long, the time it took her to do it, correct? Okay. All right. So that's going to be the that one. Now we have the distance from D to B, which is 8 minus x divided by 8, correct? No. You cannot cancel out the 8s. You could change it to 1 minus 8x over 8, yes. Okay, so my total time is the addition of those two values, right? Because this is the boat and this is the run. Right? So you can start to see how when you're looking at these, it's you have to start looking at them in pieces to break them down. You can't look at the problem as one whole thing and go, okay, here's the answer. Even when we did the can with the surface area, we broke it down. We looked at figuring out those pieces to come up with. And that's what makes this stuff so difficult. Like, in all honesty, this isn't easy. But if you start looking at it in pieces instead of trying to look at it as the whole thing, you will not get overwhelmed by it and frustrated, which is the worst possible thing you can do when you're trying to figure out a problem. Okay? All right, so that's why the picture really helps. Because having that space in there is like, okay, now I've got to figure out where this is. You can start to see, okay, now I got pieces that I can try to figure out. Okay? All right, so are we good with the equation that I have right now? All right, so now I've got to figure out basically where x is going to be. So we're looking at how long this piece is here. All right, so I've got, what was my, so my time is the square root of 9 minus x squared over 6 plus 8 minus x over 8. All right. So I need to find my t prime, right? Oh, you're right. It was. So I need to find my t prime. So I need to find my derivative of this. Yep. I have to do the chain rule. All right. So let's look at these in pieces. So again, don't sit there and try to do this all at once. So let's look at the square root of 9 plus x squared over 6. The 6 we can just ignore for right now, right? That's just a constant. Yes. No. Hold on. Let me get another page and I will show you. 9 plus x squared. If x was 5. 9 plus 25 is 34, so that's the square root of 34, right? And you're telling me the answer is the same as 3 plus x, right? That's what you said, right? Square root of 9 and the square root of x is 3 plus x, right? She's second thinking what she said now. Which would mean this would be 8, and that's not true. You can't break things up with addition. If this was the square root of 9 plus x squared, then you could cancel that and that. But that is not that. Okay, so you can't just do that with the breaking down of the pieces. So no, I can't take the square root of 9 plus x squared.
Would you break it up into those difference of squares?
No, because the difference of squares would give me two separate parentheses. I'd have to have a perfect square trinomial in there to be able to do it. So in essence, you don't have the middle term. So that's really what makes it, you can't do that. All right, so going back to this. So now I'm basically taking the derivative of the square root of 9. So I have that plus, what's the derivative of 9 plus x squared? So I have to do the chain rule, right? What's the derivative of 9 plus x squared? Is 2x. And then the derivative of the square root of u, for example, remember that's that 1 over 2 squared of u. Remember that's the thing that comes up really a ton. So it's 2 9 plus x squared. So my 2's will cancel out. So this piece over here becomes x over 6 square root of 9 plus x squared. Now let's look at this one. So again, I can pull the 1/8 out. So what's the derivative of 8 minus x? What's the derivative of 8 minus x?
-1.
-1. So it's minus 1/8. Again, do them in pieces. Yep. So now I got to set this equal to 0. So 0 equals x over 6 square root of 9 plus x squared minus 1/8. We'll bring the 1/8 over. We can now cross multiply. So I have 6 square root of 9 plus x squared equals 8x. How do I get rid of the square root? Because I really don't like that square root there. If I square everything, right? My square root would disappear. So 36 times 9 plus x squared equals 64x squared. So 36 times 9 is 270, 324. So x equals what's the square root of 324? Can't do that one. I can divide them both by 4. So I get 81 over 7. So I get 9 over the square root of 7. So that's X. Now, this one would not necessarily be the easiest one in the world to come up with the second derivative of. So this one's one of those ones, just plug in the numbers in is probably the fastest way to do it. So if you plug in the numbers, which we already basically did the two endpoints, you get 1.5, which we figured out for 0. We got slightly less than 1.5, 1.42 to figure out for the, if we ran it all, or if we wrote it all, and this one will give me 1.33. So that's the minimum value. Again, calculator, you're going to be your friend for plugging them in. So again, not something that everybody is going to do. But I just watched the Iditarod the other day, or like actually the beginning of March, the Iditarod was going off in Alaska. Anybody know what the Iditarod is?
It's the dog.
Yeah, it's a dog race. So now they have certain points that they have to actually hit, but between those places, they can go a variety of different ways. And sometimes going a little off trail might end up giving them the faster time, which allows them to be able to possibly win than staying on the trail and going along. However, on the trail, you might be able to go a little bit faster. So they got to figure out, okay, is the distance going to be saved with the time that I'm going to take having to trudge through the snow, the deeper snowpack? So it's like the top bushers and everything else do some of this stuff and figure this stuff out. So when they're in their downtime at the camps, when they're looking at their maps and everything else, they're figuring this stuff out to figure out the fastest way to do that. Another place that uses this quite often is shipping and plane routes. Why would they care about being able to do it as fast as possible?
Yes.
It's less gas. Okay, it's less fuel. They want to minimize the distance traveled. Okay, so they figure out the routes that are going to minimize that distance. And when they're coming from west to east across the US, they might plan the route so that they hit the jet stream, which will go in a little bit more speed and not use more fuel. So the people who actually are going through and calculating out the plane routes actually do some of the stuff as well. So it does have its uses. I'm not saying you're all going to do it, but it does have its uses. All right. Let's look at another case where it's used. This is why so in all honesty, this is why math teachers are at a premium. This is why like almost every school district in the entire country wants math teachers. Because if you're a mathematician by trade, every single field out there wants you. Everyone. There's not a single field out there that does not use mathematics in some way or form. And there's a lot of fields out there that the people in those fields have no idea how to do math. So they're going to pay really good for good mathematicians. And education doesn't pay very well. So it's like the other direction, you think like, okay, English teachers and stuff like that, or history teachers, people who've studied those, like there's not as much of a need in the fields for those people. So that's why there's not a need, like there's a lot of teachers out there that do that because I can't make money doing this, so I'm going to go teach it. So it's like that's why becoming a mathematician is a very lucrative career.
So, like, the difference between like math and teaching, it's like math is always kind of changing, it's always new stuff.
Actually, it's the opposite. Math hasn't changed in hundreds of years. There's new ways to teach it. Yeah, there's new ways to teach it. There's new ways that it's being applied. Yes. But the actual like core concepts of math haven't changed in hundreds of years. That's actually the one nice thing about math as compared to like science and stuff is it really doesn't change. And honestly, a lot of the stuff that we teach you and how we're teaching you was developed before there was calculators and computers. So like when we're looking at curve sketching and stuff like that, we have a computer that could graph it for us now. It's fine. The concepts that were done were before you had a computer that could graph it for you, so you had to do it by hand and figure this stuff out.
You're gonna integrate AI with using math.
Absolutely. Absolutely. But again, it will be able to do the calculations faster, but it won't be able to really interpret those results and be able to take a problem like this and say, okay, where am I going to be able to maximize? How am I going to be able to do this? Like those are the things that you still need that human impact, that human connection for. I think AI at some point will get there, but when it gets there, lots of other things are going to go wrong, or lots of other things are going to break down before that point. It's like, I'd be more worried about the writers and stuff like that because AI is going to take them out real quick. Yeah. So once it actually gets better at like grammar, it'll be able to write the TV shows and stuff like that. No problem. Your movies, your TV shows, stuff like that, AI will be writing those within the next couple of years. All right. A store has been selling 200 TV monitors a week at $350 each. A market survey indicates that for each $10 rebate offered to buyers, the number of monitors sold will increase by 20 a week. Find the demand function and the revenue function. How large of a rebate should the store offer to maximize revenue? All right, so we want to make the most money as possible. Anybody taking economics? You will do things very similar to this in your economics class. All right, it's when you're looking at demand functions, break-even points, all that stuff. It's all, if you know the calculus side of it, it's going to make your life a lot easier. So, how do you figure out revenue? That's the easier of the two pieces. Right. So your revenue coming in is going to be the amount of money that you're bringing in. Your costs would be how much it's costing you to make it. And you subtract those and get your profit. We don't need the profit in this case. We're literally just looking at revenue in this case. So what's my revenue each week as of right now? Right. It's 200 times 350, which is what? 70,000. So they're bringing in $70,000 a week. All right. They're saying, though, that for every $10 I take off, I'm going to sell an extra 20 TVs. So how am I going to set up this equation? So 350 minus 10x, because I don't know, right? times 200 plus 20x. Because again, it's the same concept, right? It's the amount of TVs I'm selling, which is this, times the price, which is that. All right. So what do I got? Weekly. Yeah. It is 20 times X. Because it's 20 times however many rebates I offer of $10. So if I offer one rebate of $10, I'm selling an additional 20 TVs. If I offer $20 off, I'm selling an additional 40 TVs. If I'm offering $30 off, I'm selling an additional 60. Right. Exactly. That's where that X comes in. All right. I need to find my derivative, but do we want to find the derivative of this or do we want to FOIL this out first? Let's FOIL it out first because my derivative is way easier. So I know that one. That's 70,000. My middle term will be 700. So 6 plus 600x. And then minus 200x squared. Or is it 6,000? Oh, 6,000. Oh, you're right. It's 5,000. 2,000, 7,000, 5,000. Yes. Okay. What's our prime? Yeah. It doesn't matter. It's the same thing. You were negative 400x plus 5,000. Yes, you did. Yes. All right. So set that equal to 0, right? So negative 400x, or actually, no, I'm just going to do it that way. 5,000 equals 400x. So 5,000 divided by 400 is what? 12.5. And if I found my second derivative, I get negative 400, which means that's a maximum. So that will maximize my revenue. Well, and now at this point, you have your choice, right? Do 12 or 13. They're both going to come out to be the same thing. Or do the 12 and a half and just offer an extra $5 off. And you're like, it's like, so you'll actually maximize your money if you do the 12 and a half there. So how much am I selling the TV for? So X is 12.5. So I'm taking off 12.5 times 10, $120, $125, right? So my TV would be 225. And I would be selling 20 times 12.5 is 250. So I'd be selling 450 TVs a week.
But if it's 225, wouldn't that be like 12 and a half rebates?
Yes.
So
Yeah. So it's, you can either do it that. So in this type of problem, the store would have a choice. They could do 12 rebates or 13 rebates. And actually, it would come out to be the exact same profit because it's a parabola and it's symmetrical. So 12 or 13 would give them the exact same amount. Or they could choose to offer the $5 rebate and maximize at the peak. That's just dependent. Got to remember, a rebate's literally just a sale, so they could cut it off by $125. Like that wouldn't make a difference. So this problem assumes a perfect situation and world. Okay. That demand goes directly with the cost of the things. Like, but after the 12 and a half, the profit starts to drop off. The demand's increasing, but the price is dropping to a point where the demand's not keeping up with the amount of money that I'm going to make. So this would be the ideal place in that spot. But you also got to think about, this is just revenue, how much the TV is costing us.
That's how much money we lost.
That's how, no, that would be how, the cost would be how much money. That's how much money I've made. The revenue is the amount of money coming in. We don't know our profit. We know our revenue. So our revenue, if we multiply the 225 times 450,
To get a TV.
yes. So right now they're making just over $100,000. That's their profit at that point, up from $70,000 or their revenue from previous. So they were making $70,000. With this, they're making just over $100,000, $101,250 to be precise.
225 is first.
Yes. Yep. That's how much they're selling each TV for. I just multiplied the 300 minus 10 times 12.5.
Yep.
So, but that doesn't tell us our profit because we don't know our costs. If the cost of the TV was $250, I'd now be losing money. So you need that information as, I guess we're going outside.
May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the
Out.
first exit or stairwell.
So go to that hallway and down.
Do not use the elevator. Thank you. May I have your attention, please? May I have your attention, please?
I'm just gonna leave this
There has
here.
been an emergency
I'll lock the door, so it's up to you.
to the closest exit or stairwell and leave the building. Do not use the elevator. Thank you.
If you go back, if you take a left,
May I
go
have
down
your
that
attention,
hallway,
please?
that's the
There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevator. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please? May I have your attention, please? There has been an emergency recorded in this area. Please proceed to the closest exit or stairwell and leave the building. Do not use the elevators. Thank you. May I have your attention, please?
All right. I'm gonna end the recording.
Yeah.
I totally forgot to do that. Okay.